Hello students, we are going to study the laws of motion and we first start by fundamentals and basics because if fundamentals and basics are strong, we can easily understand the complex concepts and solve the questions easily. So let's see the first topic of laws of motion, that is types of forces. The first type of forces is field forces. So what are field forces? These are the forces in which contact between two objects is not necessary. For example, gravitational force between two bodies, electrostatic force between two charges are the example of field forces. Gravitational force like weight is equal to mg of the body comes in this category. And next we will see the contact forces. Contact forces are of two types. First is normal reaction. So what is a normal reaction? Two bodies in contact exert equal and opposite force on each other. If the contact is frictionless, the contact force is perpendicular to the common surface and known as normal reaction. What does it mean? Let's just say there is a object of mass m. It is it is standing at rest on the ground. Then the ground will exert a normal reaction force on mass m block in the upward direction of the block, and the block will exert an equal and opposite normal reaction to the ground of n magnitude. Note that the direction of normal reaction is perpendicular to the surface through which perpendicular to the surface of contact. Next we will see the force of friction. If however the objects are in rough contact and move relative to each other without losing contact, then friction force arises which opposes such motion. Again, each object exerts a frictional force on the other and the two forces are equal and opposite. This force is perpendicular to the normal reaction. Thus the contact force F between two objects is made up of two forces. For example, we take an example, this is a block B and this is a block A. Block A is on the block B, and if we apply the force F1 on block A towards the right and force F2 on block B towards F2, so then this is the types of forces that are applied on the block A. Normal reaction by the block B on block A. This is the external force that we applied it, and this is the friction which is applied in the surface between A and B in the opposite direction of F1. And the forces applied on N B are normal reaction by A on B in the contact of surface and towards the block, and this is the friction force that is applied opposite to the force applied on block F2. And third we see the forces type is attachment to another body. Tension in a string and spring force comes in this category. We will have to remember 3 points. First, if a string is inextensible, the magnitude of acceleration of any number of masses connected through the string is always same. Means, for example, this is string which is inextensible. If the acceleration of this block is a, then the blocks connected to this small m will have also an magnitude of acceleration a. Similarly, we see another example of acceleration of this block magnitude is a, then the magnitude of acceleration of this Another block attached to this spring via pulley has also A. If now second point, if we have to remember, if string is massless, the tension is same everywhere. However, if the string has weight, it is accelerated, tension at different points will be different. Means the string is massless, the tension in all over the string is same. Tension here is T, tension here is also T. If string has weight, then tension across different points has different values. And third point we have to remember, if pulley is massless and frictionless, tension will be same on both sides of the pulley. Let's say this is the pulley, this is a string over it. If pulley is frictionless and massless, then the tension on both sides of the pulley is same. Let's see the three cases. First, string and pulley are massless and there is no friction between the pulley and string. So the tension across all over the string will be same, and the tension above and below the pulley is also same because pulley is massless. The second case is string is massless and pulley is not massless and frictionless, so that the tension across the pulley is different, but the tension within this portion is same, and within this portion tension is same. Next, but not the last case, string and pulley are not massless and there is a friction between pulley and string, so the tension across this portion of pulley and this portion of pulley is different, and as string is not massless, it has mass, so there are different tension across this portion T1 and T2 and the different portion here T3 and T4. Next type of force we see here is hinge force. This is the wall, this is the hinge, this is the rod. The hinge is applying a force on rod towards the wall. This is called the hinge force. To find the hinge force, there are two methods of finding the hinge force. Either you find the horizontal and vertical components of force, or you find the magnitude and direction of the force. Now let's we see some special cases and notes to remember. Normal reaction is perpendicular to the common tangent direction and always acts towards the body. It is just like a pressure force FPA, which is also perpendicular to the surface and acts towards it. For example, this is the circumstance, this is the ladder. The normal reaction at this point is applied perpendicular to the contact of surface in the above direction, and the wall applied the normal reaction perpendicular to this contact of surface N2, and it's towards the object away from the contact body that is applied on another. Let's see another case. Tension in a string is as shown. T1 goes to block A, T2 and T3 to pulley P1, T4 and T5 to pulley P2, T7 and T8 to block B, and T6 to the T6 is the tension which is applied by the wall. Here we have to know that that T1 is equals to T2 is equal to T3 is equals to T4 is equal to T5 is equal to T6, because string and pulley are massless and there is no friction in the pulleys between them, and also T7 is equal to T8. And let's see, if a string is attached with a block, then it can apply force on the block only in a direction away from the block in the form of tension. This is the block and this is the string attached, so it can apply the force away from the block. But in rod it can apply the force in any away from the block and towards the block, that is pull and push. Now let's see the free body diagram, which is very essential to solving the numerical questions and scenario questions in the physics. What is a free body diagram? A free body diagram consists of a diagrammatic representation of a single body or a subsystem of bodies isolated from its surrounding, showing all the forces acting on it. The free body diagram shows all the forces acting on a block or a subsystem. So let's see, consider an example. A book lying on a horizontal surface. The free body diagram of the book alone would be consist of its weight acting through the center of gravity and the reaction N exerted on the book by the surface. Now let's see an example. A cylinder of weight W is resting on a V groove as shown in the figure. Draw its free body diagram. The free body diagram of the cylindrical body is the weight is applied from the center of the cylinder towards downward, and the normal reaction forces by the V groove walls are applied across the point of contact, that is N1 and N2. And now let's see at another example. Three blocks A, B and C are placed on over the other as shown in the figure. Draw the free body diagram of all three blocks. So let's see the free body diagram of the block A. The weight of A is applied on the A, the normal reaction N1. The normal reaction N1 is the normal reaction between A and B exerted the normal reaction on A. A free body diagram of B. Normal reaction N1 applied by the block A, normal reaction N2 applied by the block C on block B, and the weight force of the block B. And now let's see the free body diagram of the block C. N3 applied normal reaction between the C and the ground. This is the normal reaction applied by ground on the block C. This is the weight force of the block C. This is the normal reaction between B and C, and this is applied by B on C. And now let's see the last one example of free body diagram. A block of mass M is attached with two strings as shown in the figure. Draw the free body diagram of the block. So the free body diagram of the block is the weight force, which is the mg, the T2 force which is applied by this string towards the wall, and this T1 string force by this string. Thank you. I hope you will understand the concept. If you have any doubt, you can query me. And in the next part, we will study the equilibrium, resolution of a force, moment of a force, direction of torque, zero moment, and we will start the laws of motion. First laws of motion, second laws of motion, third laws of motion. Thank you.